This video, looking at acid and base reactions, you're going to see a lot of this as review. They're all double replacement and they are very predictable as to what they're going to make. So acid-base neutralization, all acids and bases react with each other to make water and a salt. And we call this salt sodium chloride, but then any other ionic compound is also considered a salt. Those other types of electrolytes. Think about our dissociation constant stuff. Reason why this is called a neutralization is because we are creating water. And remember, water has a pH of 7, neither acidic nor basic. The other thing is, well, what we make, that other part, the salt, has no H, has no OH minus, it's not producing any of those things. So this part, this salt piece, does not have an effect on pH. How we do this through titration. And titration, definition there, determine of an unknown concentration of solution by addition of a solution of a known. So you have to know something. You have to know the concentration of either an acid or a concentration of a base, and you need to know the volume as well. So fact, if you add enough acid to base, eventually the solution will be neutral, meaning we have the same number of H plus ions and the same number of OH minus ions, actually the same number of moles of each. The other fact then is that, well, moles equals molarity times volume. So we could do the math to show you that. Hopefully you know that this is moles over liters times the liters cancel, you're left with just moles. Titration is a lab process, that it's a very exact process. It's something that we're going to practice here in the future, but we will get a very exact volume. So if we can know the molarity of that to a nice exact number, or something that's pretty precise, we can have a really good multiplication here to figure out moles. So we'll get a nice precise answer, precise and accurate answer. So for a solution in which an acid and base have reacted to neutralize each other, the amount of acid equals the amount of base. This is the neutralization point when these two things are equal. So moles are equal, which means molarity times volume is the same as the other molarity times volume. Looks a whole lot like something we've done before. That whole M1V1 equals M2V2, or M concentrated times volume concentrated, that whole thing. We've used this before. Math looks the exact same. So if we know the concentration of one of the solutions, we can find the concentration of the other simply by measuring volumes. And that's what titration does. It's a very exact way of measuring volumes using a burette. But how do we know when the solution is neutral? So you're going to keep adding volume. You're going to keep adding volume of an acid or a base. How do you know when? Well, you need something to tell you. You need something to indicate this. And in chemistry, we call these indicators. Indicators, what they do is they change color at a certain pH. Hopefully we can pick one that changes at 7. If not, we can do some calculations to kind of correct for that. But just depends on what indicator you choose when they change color. The indicator stuff we'll talk more about with lab. For here, though, we want to use that molarity of the base times volume of the base, that equation. So if I have 25 milliliters of 2.4 HCl, that's required to neutralize this much base. How do we find the concentration? So here's your bad artist rendition of what titration looks like. Titration looks like, there we go. Titration looks like a burette, which is just this long skinny tube that let me fix my board here. So long skinny tube, and then kind of comes to a point like a pencil, and just kind of drops come out, one drop at a time. We can control this. And then underneath it, we are going to have an Erlenmeyer flask. So in our Erlenmeyer flask, we want the unknown. So this is our, if I can spell, O-W-N. This is our unknown. We do know it's an unknown concentration, but we do know the volume. So we know that there is 13 milliliters in here. So there's some volume there. We know the concentration of this. We know that inside our burette there's a solution of 2.4 molar HCl. So there's our acid. And we drip acid, we drip acid, we drip acid, keep going until eventually our indicator shows some color change. And once we get that, we know we've hit that neutralization point. That neutralization point comes at 13 milliliters of that acid. So we can now do our calculation. We have MV equals MV. I'm just going to write A for acid and B for base. The molarity of our acid was 2.4. The volume of our acid was 13 milliliters. I'm going to convert that to liters really quick. So 0.013 equals molarity of the base. Well, we said it's unknown. So equals my unknown, my X, times its volume. Did I get that right? Ooh, it was 25 milliliters of the acid, my bad. Let's fix that. So 0.025. Fix that over here. This is 0.013. Alright, that looks better. Everything's set up right. Solve for X. X equals, plug into my calculator here, 2.4 times 0.025 divided by 0.013. X equals 4.6, and we only get 2 sig figs because of this guy here. So 4.6, and what was X? X was a molarity, so we need to make sure we have our concentration in molarity there. So that's how we find an unknown concentration of base. Next question here. What volume of 0.0034 molar nitric acid is required to neutralize this much? So this question is not asking for, it's not asking for concentration. It wants to know, okay, maybe this is something we would do before lab. So we want to make sure we get kind of close to that number. At what point should that indicator change, or what point is that neutralization point? What volume? So how much should we add to get to that neutralization point? It looks the exact same. So we have our burette here, have our Erlenmeyer flask. This one looks fancier. Inside our Erlenmeyer flask, it says we have 1.00 molarity and that there is 1 liter, so it's a big flask. And we want to know how much of our acid in our Erlenmeyer flask with a concentration of 0.0034 m. We want to know how many, it just has volume, so let's go liters. How many liters? Same equation. MAVA equals MB VB. Molarity of the acid, we look over here, we know. So 0.0034 times volume of the acid. We don't know volume because that's what it's asking us to find. How much do we need? Is equal to molarity of the base, 1.00, times, well, the volume of the base, 1.0. I can do this math in my head. 1 on this side. So 1, and then over here, 0.0034x. Well, x equals 1 divided by 0.0034. If we plug that into our calculator, 1 divided by 0.0034 equals, holy smokes, a huge number, 294. If we look, we only get 2 sig figs here, so equals 290 liters. That doesn't seem right. If we go back and look, well, this is really small. That's really small, 0.0034, where this is a lot bigger than this number. So having a big number here, having lots of this to neutralize this, I got to add a lot of this because it's not bringing many H pluses every time, or this concentration. So this should be a big number as well. Most of the time you're not going to get weird numbers like this unless I start giving you, something that's really small like that. So that's neutralization reactions. Kind of the idea of titration. You'll see that in lab, but that's how we do the calculations. Calculations are fairly simple for this, using an equation very similar to one we've used in the past.